Okay, this is part 5 in this series devoted to Improv Card Magic. Now today we will begin with 14 card packets. Okay, so I have a shuffled deck of cards here. And as you can see, we're going to look at something I haven't shown you yet. It's a kind of cool system for keeping track of the number of red and black pairs in such a way that you don't mentally become overwhelmed with the job. Okay? In fact, why don't we just take a minute and kind of explain this. So let's say we have these 14 cards here, and these are the colors of the cards starting from the top of the deck. So red, red, black, 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 and so forth. Okay, so here is a very interesting, simple system for keeping track of the number of red and black pairs if a person wants to go that route. So what you do is you associate with 2 red the number 10, okay? And then associate with 2 blacks the number 1. And then opposite colored pairs count as 0, so essentially just leave those, ignore those. Okay, that's probably the easiest thing mentally. So just skip those. So I see a red pair, so I think 10, and then I see a black pair, and I add 1 to it. So now in my mind I'm just thinking 11. Okay, so that's the number I'm thinking. Okay, nothing. Oh, I got another 10. Well, 10 plus 11 is 21. Come over 1. Oh, I got another 10 plus 21 is 31. And then over here, oh, I got a pair of black cards. So we add 1 to that, 31. So we get 32. So in my mind, I just need to remember the number 32. And remember that the tens place, the digit in the tens place, tells me how many red matching color pairs I have, and the ones place tell me how many black color matching pairs I have. So if I can just hold on to the number 32 throughout the performance, I can reconstruct the number of pairs that will either be red or black. Okay, so I thought this is a fun system to share with you, especially as the packet sizes here are getting a bit bigger. Okay, so as always, we need 3 random piles here of 14 cards each. So let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 3 piles of 14 random cards each. So what we'll do is we'll go ahead and just put these out of the way for a moment. And then if you remember, what we do is we pick up any of the 3 piles, actually. And then at the start here, just for the sake of the performance, my presentation here, we're free to look for an AMP mirrored or 2-cycle structure for the first pile that we pick. So maybe we'll choose this one to work with first. Okay, so just keep in mind, we're going to take a look at all 3 structure types for this one. Now, as we choose a structure for this one, it's going to limit the number of possibilities for the other 2, right? Okay, so let's just see how we're doing. Okay, so here we go. So we have 14 cards, getting kind of big. Okay, so let's go through. In fact, we could probably just use my system right here if you would like. So remember so we're going to look at AMP. So a black pair, we think of that as a 1. So we have 1. Here's another black pair. 1 plus 1 is 2. Opposite pair, ignore. Oh, a red pair right here. So we add 10 to the 2. So it's 12. So another red pair would give us 22. Nothing here. And then we get another red pair, 32. We actually got the number I used as an example. That's funny. Okay, so that's viewing it as an AMP. So we get 32. So we'll go ahead and view this. Treat this as an AMP. Okay, very good. Okay, and where all we need to do is keep in mind 32. So if you need to jot that down, that's fine. Remembering a 2-digit number, if that's the only thing you need to remember, is probably not too much for most people. Okay, very good. Okay, so let's take a look at the next pile and just see what Lady Luck has given to us. Now, since we've already taken up our AMP structure, we're limiting ourselves kind of artificially, superficially, to a mirrored structure or a 2-cycle structure. Okay, so glance at it as a mirrored structure. Looks like it could be actually pretty good if we use our little system here. So let's look. So as a mirrored structure, what do we get? Well, same suit even. So a black pair counts as 1. So we get 1. Here's a red pair. That's plus 10. So it counts up to 11. Plus another 1 for a black pair. That's 12. Nothing. Plus another 10 for a red pair. That's 22. And then a black pair that add 1, 23. Another black pair, 24. Ooh, that's kind of nice. So if we just hold on to the one number, 24, think there's 24 hours in a day, right? Or something like that. We could reveal in the end that we've put out pairs where 2 of the pairs are red cards and 4 of the pairs are black cards, and the other pairs are non-matching color pairs. So I think we can hold on to 24. So 24. Okay, so we'll put this in the middle. Now, for the last one, we're going to do something different that we haven't done yet in this series. Okay, so what we're going to do is, of course, they have 14 cards, and so what you have the spectator do is just kind of randomly flip these face up, face down, mix them thoroughly. Okay, and you can keep flipping if you want. Just kind of randomly mix them face up, face down, and then just, mix them together in a haphazard way. Okay, so just so you know, I'm not controlling anything here, and you wouldn't either. Okay, so then you just kind of clear these up like that. Okay, and then what you can do is just fan these out. Now, it is true, using an AMP structure would be the easiest for this little card flipping variation. And it just occurred to me you could use a similar sort of system that I just used for the black and reds. So for example, so we're still kind of practicing here, but for example, if we now associate, let's view it as an AMP just to practice here. If you see a pair like this where one's face up and the other one's face down, you can count that as a 0. It's kind of like being of opposite color. Okay, so it's very much analogous to what we were just doing. So this would be like a 10, right? A 10's place. So we'd have 10, nothing, nothing, another 10. So it's 20 and nothing there. So if in your mind's eye you can hold on to the number 20, where this time the number 20 is telling you in the tens place, namely the 2, that there are 2 pairs of cards where both cards are face up. And since we have a 0 and that 20, that means none of the pairs that will reveal at the end consist of cards that are both face down. Okay? How about as a mirrored structure? Why don't we just practice here? So if you come on either end, so these are opposite orientation, we call it. So just instead of opposite color, I think opposite orientation, face up, face down. Opposite orientation. Oh, these are both face up, the queen and the 7. So think of that as a 10. Next pair, opposite orientation. Oh, we have another up-facing pair. So it's 10 plus 10 is 20. And then we have opposite orientation, opposite orientation. Oh, that's interesting. So if we view this as either an AMP or a mirrored, you get 20 as our secret code for revealing how many pairs are face up, how many pairs are face down, and how many pairs consist of a face up and face down at the very end. Okay, well, since we're needing, if you remember, since we're needing a 2-cycle here, why don't we go with whatever nature gives us. Well, the 10 and the queen are related, and they're both face up. So think 10, come over 1. We have a pair of face down cards, so that counts as a 1. So that counts up to 11. Move 1 over. Oh, another pair of face up. So we add 10, that's 21. Come over here, we get nothing. Come over here, we get another pair of face up cards. So we had 21, 31. We get another pair of face up cards. That's 41. And then we get another final pair of face down cards. So 41 becomes 42. So why don't we go with that? I think that's pretty strong, actually. So if you want to think like 42, where the idea is, maybe I'll even write it out since this is kind of new here. So the tens digit tells you the number of, we'll say, face up pairs that will reveal in the end, and then the ones place, namely the 2, tells you the number of face down pairs. Okay, so these are just notes to help you out educationally within this video itself. You wouldn't show the spectator all of that information, of course. Okay, so let's go with that. I think that's pretty strong, actually. Because if you think about it, see, 4 pairs plus 2 pairs, that's 6 pairs. That only leaves 1 pair. So we're going to match these up where all of the pairs have the same orientation within the pair, except for 1. That's pretty darn surprising, actually. Okay, so we're ready to move on here. Okay, so we have our 3 special piles, and we've made note of important information for each. So let me go ahead and reveal the sequence of shuffles that will happen to use here. Now remember, there's nothing really sacred about the particular chain of shuffles that I happen to choose. I'm just using our diagram, our table, which I'll bring up in just a second to remind you. So maybe I'll slide this underneath if I can. And you want to be able to see all that, I imagine. So we'll slide that up. Just put our pins in, even though they don't seem to be doing much, to keep the paper from moving around too much. Okay, so we'll leave these up here to help kind of cover up the information so that we don't get too confused. Okay, so this first one is an AMP, and if you remember, the number associated with this little packet is 32. Remember that, 32 right there. And the tens place, namely the 3, tells us that we will have in the end 3 red pairs, and the single digit 2 tells us that we will have 2 black pairs. Okay, so that's the deciphering of our number 32. Let me bring up our shuffle table here so you can see that we're following things faithfully. Now this is an AMP, and as we've seen in previous videos, a Bessie 2-2, which is on line 16 there on the left, it will preserve an AMP structure. So this is where you take 2 from the top, 2 from the bottom, 2 from the top, 2 from the bottom. So you go 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top. That is a Bessie 2-2, and it preserves AMP structures. Now, in our table on the left, if you look at line number 11, the up jog, that will always take an AMP to a 2-cycle. So let's go ahead and do that. Now, it can be an even up jog or an odd up jog. Either one will accomplish this. And you can have the spectator decide which of those two to use. Strip this out with random stacking. Maybe the spectator wants it stacked like that. It is now a 2-cycle. Being a 2-cycle, we can now cut the cards freely, have the spectator do that. Or more powerfully, we can perform a Charlier shuffle, top to bottom, bottom to top. Okay. This is one that I have a video for, you remember? So top goes on the bottom, some from the bottom go on top, top to bottom, some from the bottom go on top, top to the bottom, then maybe this bottom one goes on top. All of that movement of the cards is equivalent to just cutting the cards at some location. Hence, it is still a 2-cycle relative to the pairings that we made note of. Now, a common way to go from a 2-cycle to a mirrored structure is to use a Klondike shuffle. And that's in our chart on the left. It's line 14. So the Klondike shuffle will convert a 2-cycle structure to a mirrored structure. Now this is where you take the top and bottom card off as one and then just drop them on the table. And do that until all of the cards have been moved from one hand to the other. It is now mirrored. Now once it's mirrored, we have the stay stack principle, which opens up a whole universe of structure preserving mixing of the packet. But we'll go ahead and just do we'll just do an LR, left, right, with random stacking of the left pile on top of the right or right on top of the left. The spectator can decide this. Okay, it's still mirrored. Now just make note of the fact that we can deal out as many piles as we like as long as that number is a divisor of our packet size. So 2 divides into 14 evenly, and so does 7. So technically, and we'll probably use it over here, you could deal out into 7 piles and then stack from left to right or right to left, and it will preserve a mirrored structure. Okay, now to go from a mirrored to a 2-cycle, one of several ways will be to use the Monge shuffle. Now that's line 13 in our table on the left. So if you want to take a look at that, we can do an over-under or an under-over. Okay, so maybe the spectator will say, do a over-under. Okay, so over, under, over, under, over, under, over, under, over, under, over, under, over. Okay, we are back to a 2-cycle. Okay, now what we're going to do is we're going to deal the cards into 6 piles. Okay, just like you would for a, we're now going to deal the cards into 7 piles using, quote, LR dealing, but we won't stack them this time. Okay, so why don't we'll go like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so since this was a 2-cycle, just think about it. If you think back to our 2-cycle structure, you can think of it as like 1, 2, 3, 4, 5, 6, 7, followed by 1, 2, 3, 4, 5, 6, 7. That's a 2-cycle structure. So if we did 1, 2, 3, 4, 5, 6, 7, and then we did 1, 2, 3, 4, 5, 6, 7, what that would do is it would group together the special pairings. Like all the, quote, 1s would be together, the 2s, 3s, 4s, up to the 7s. So now we have what's called a DMP. Okay, so DMP means we have distinct mirrored pairs. So we're essentially done at this point. This is what we were hoping to find. Okay, now if you remember, the special number that we remembered, we squirreled away for this, was the number 32. Okay, and the 3 tells us there's 3 red matching pairs, and the 2 tells us there's 2 black matching pairs. Okay, so what you could at this point, there's a lot of ways to proceed, but you'll probably, in this case, you'll probably want to divine that before you show it. And so you can come over here and go, well, I'm trying to get a feel for, you know, like how many of these pairs are opposite color, how many are black cards, and how many are red. For the red pairs, I'm just in my mind's eye, I'm seeing the number 3. It's kind of weird. So I think there's 3 matching red pairs. Okay, what about black pairs? Are there any pairs here of black cards? No. Oh wait, no. I think there are some. I think there's. Oh yeah. Okay. Yeah, I can see it now. It's 2. We have 2 of these matching in color, and they're black. So we have 3 red pairs and 2 black pairs. Let's see if I divined that correctly. Was I sufficiently sensitive to perceive this without actually looking at the pairs? Okay, so let's see. What was it again? Yeah, 3 red pairs and 2 black pairs. How did we do? Oh, there's a black pair. And we said there'd be 2 of those. Oh, check it out. Oh, but we don't want any of these to be black. So there's 2 black pairs, and then we're thinking there's 3 red pairs. No, that's non-matching, so it doesn't hurt yet. Oh, we got 1 red pair. So there's got to be 2 of these have got to be red pairs for me to be correct. Let's see. Oh, I got a second one. Oh no, stress. So we want 1 of these over here to be a red pair, 1 of these to be a red pair, and the other one to be non-matching. Okay, why don't we do this one way over here? It's essentially off the... Oh, we got 1. Okay, so right now we have... Maybe I'll put it like this. Our prediction is true. As of this moment, we have 3 red pairs and 2 black pairs. So I'm just praying that these are not of the same color. Otherwise, I've blown it here. I did not correctly feel what the universe had given me. Oh, those are of opposite color. We nailed it. We got exactly 3 red pairs and exactly 2 black pairs. Look at that. Aren't we amazing? Okay, so that is the first one. First little demonstration. And hopefully you can see how well our little system worked for just quickly noting, so 3 red pairs, 2 black pairs, and just having to remember just 1 2-digit number to finish this. I mean, that's not too much information to require someone to remember. Okay, so let's go ahead and move on to our mirrored structure that we made note of here. So the middle column here. You may recall, what is it that we made note of for this packet? Do you remember what number we needed to remember? It's a 2-digit number. Yeah, 24. There's 24 hours in a day. So remember, so the number we're needing to remember. Now, as always, you need to realize that for the sake of this educational video, I'm doing 3 presentations in one. Now, you normally would not do that. You would choose just any one of these for a particular packet, okay? So you're really not having to remember all 3 of these. That might be too much for most people, including myself. You're just needing to remember just one of these for a performance. And so here we just squirreled away that 24, and we kind of associated it with, oh yeah, that's the number of hours in a day. That might help us remember. And then, of course, remember the 24. What does it mean? The 2, the tens place, tells us the number of red pairs that we're going to reveal in the end. And the ones place, namely the 4, tells us the number of black pairs. Okay, very good. So just kind of keep that in mind. So we're viewing it as mirrored right now. Being mirrored, of course, we have the stay stack principle. One of the consequences of the stay stack principle is that a Pharaoh in and a Pharaoh out shuffle preserve mirrored packets. Okay, and you can see that if you go to line, so on the left in our table, line 12, it says Pharaoh, and it will preserve a mirrored structure. Okay, so do you remember how a pharaoh goes? Okay, so you just kind of fan out the cards so you can kind of see them. So what we're needing to do is split the cards exactly in half. So you can just break these off like that. And now you're free to interlace these in any way that you like, but they do need to be perfectly interlaced, every other card. Now technically, one of these, quote, interlacings gives rise to what's called a pharaoh in, and the other one will be a pharaoh out. Well, it ends up that both of those preserve mirrored structures. So isn't that wonderful? Now, being mirrored, we can convert it to an AMP by way of the LR to the negative R. Okay, so that's on line 23 on the left. Okay, so that will convert a mirrored structure to an AMP. So let me just remind you of how this works. So it's a dealing out of half the cards, which is 7, but when you go to deal out the next level, you don't do it in the same order, you do it in reverse order. That's why the R is up in the exponent, okay? So you can go like 1, 2, 3, 4, 5, 6, 7. Now, instead of continuing 1, 2, 3, 4, 5, 6, 7, you now do it in reverse. The last one dealt, so we put the next one on top of that. We just go in reverse all the way to the very first card dealt. Okay? So it's like a 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7 in reverse. Okay? Okay, now it is true that we can stack this. Imagine these on a line here. If we had them on a line, we can stack from left to right or right to left. Now there are some other stacking that you can do that I'm not going to show you here. It's called judicious stacking. I talk about it extensively in other places on my video. But here, what would have been nice for you to do, actually, is if I hadn't limited my screen space, what you could do is just deal out 1, 2, 3, 4, 5, 6, 7. And then the next card goes there, 1, 2, 3, 4, 5, 6, 7. Okay, so it's less likely that you'll get confused if you just do it on a line, and it makes the dealing backwards a little more intuitive. Okay, now we're going to stack what's equivalent to a left to right or right to left. Well, this is the first pile, so if we stack from right to left, it's like going clockwise. If we stack from left to right, this is the first pile, and we go counterclockwise. Okay, so just be aware of that. If you want to do this circular arrangement, that's fine. There's just a little bit more to pay attention to not make a mistake. So at first, I think it's safest just to put them out on one big long line. Okay, so let's say they want to stack them sort of in the opposite order to which we started to deal these out. Well, that would mean this is the last card, last little pile, so you'd go in reverse order. So this would be analogous to stacking from right to left, okay, if the original dealing was left to right, okay? So if we haven't made a mistake, this should now be an AMP structure, and we'll find out in a minute if we made a mistake, because it's not going to work out for us. So to go from an AMP to a mirrored, a really nice way to do it is the Mange shuffle. Mange is on line 13, and that will convert an AMP to a mirrored structure. And Mange comes in two varieties, over, under, and under, over. So maybe they'll ask for an under, over. So this is where you push the top card into your other hand, and then it's under, over, under, over, under, over, under, over, under, over, under, over, under. Okay, that's a Mange, under, over. It's guaranteed to convert an AMP to a mirrored. Now, since this is mirrored, we still have the stay stack principle. And in particular, we can deal out into 2 piles or 7 for the simple reason that 2 and 7 are divisors of the packet size 14. So I don't know, maybe I'll try something that I'm not sure if it's going to work on this screen, but I'm going to try to deal these out way up here into 7. So we'll get 1, 2, 3, 4, 5, 6, 7. Not quite as nice as I was hoping. 1, 2, 3, 4, 5, 6, 7. Okay. So once again, if you want to just do it on a long line, safer. We can stack from left to right or right to left. Maybe they'll go from left to right. Well, this is the first one dealt. So this would be like stacking from left to right. Okay. Now, so because of the stay stack principle, this is still mirrored. Okay. Now, another thing that we can do is two identical overcoats. Okay, now I think we've done this in an earlier video. It's on line 7 in our table on the left. So an overcoat is where you deal out half or more of the cards and drop the rest on top. That's an overcoating of the cards. Well, if you perform two identical overcoatings, it will preserve mirrored structures. Now the cards will be in a different order, there's no question. But the mirrored configuration of the cards relative to each other is still there. It's unharmed. Okay. So one way to do it is if you know their first name has somewhere between 7 and 14 letters, you could just use the first name of the spectator. That might be nice to personalize it. Or you can just ask for, we need a random number, let's say between 7 and 14, since we only have 14 cards here. So what number would you like us to go with? And they might say 9. Okay, that's great. So what you do here is you deal out 9 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9. Drop the rest on top. And then you perform that same dealing one more time. You have to do it twice. That's the reason for the 2. So by the way, the 2 and then the next thing that looks like a 0 is actually an O-C. O-C is overcoating. Okay, I just want to clear that up. Okay, so we need to overcoat 9 cards a second time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And those two actions taken together are guaranteed to preserve mirrored structures. Okay? And like I said, if you can come up with a word that relates to the spectator in some way, or maybe you know their favorite ice cream is chocolate. Well, chocolate has somewhere between 7 and 14 letters, and so you could spell it out twice and say, well, I'm going to give you 2 scoops of chocolate ice cream, okay, or something like that. So just use your creativity. Okay, so this is still mirrored. Okay, so now what we're going to do is we're going to use the Klondike Shuffle, and we're going to put out even sized piles of cards and then randomly stack them. Isn't that amazing? Okay, so if this is mirrored, a Klondike Shuffle, what it does is it brings together those special pairings that we noted at the beginning. In fact, if we just do a Klondike Shuffle and deal into a single pile, it will convert it to an AMP, and you can see that. Look at the chart, line 14. The Klondike Shuffle always converts a mirrored structure to an AMP. But what we're doing differently here is you just have the spectators tell you when to stop, like dealing out pairs. Maybe they'll want a whole bunch here, that's fine. And then maybe one here, okay? And now you're free to have the spectators stack these or tell you how to stack them in whatever order they like. So maybe they want this one first, followed by the one down here, and then maybe the one way up here, and then the one down here. Okay, these are all free choices made by the spectator, but guess what? It does not hurt the fact that this is an AMP. Okay, and now we're going to do something that we haven't quite done in this way. We're going to use an up jog. Now, as you can see on the chart, line 11 on the left, an up jog converts an AMP structure to a 2-cycle structure, okay? But instead of stacking the 2 halves that come from doing an up jog, we're going to just set them down as separate piles. Well, when you do that, you get something called coupled piles. And we talked about this in an earlier video. So let's go ahead and just bring up our larger hidden structures diagram here. Okay, so here with a 2-cycle structure, if you were to push off 50% of the cards, that's what the P is for, you would create what are called coupled piles, okay? So coupled piles are 2 piles where at each level the cards are, quote, related. They consist of the special pairings that we made note of, okay? So we're really just using the even or odd up jog to kind of get what are called coupled piles. And those 2 piles randomly stacked together will always give you a 2-cycle, okay? But we're not going to stack them this time. Normally we'd stack them. What we're going to do differently is just set them down like that. And now from here, what we know is true is these are coupled piles, which means these 2 constitute one of the pairings that we made note of at the beginning. So what you do is you just say, okay, these 2 are little friends. They're on the same level of each pile. These 2 get along really well. So we're just creating little piles. These 2, they just feel like they belong together. How about these 2? Yeah, we'll put them together. These 2 maybe in the middle there. These 2 together. And then the final 2 together, okay? So that gives us 7 pairings. Well, at this point, we have, quote, a DMP, right? Distinct mirrored pairs. And now we're ready for the reveal, right? And if you remember, the special number we remembered was 24. Well, what's the 2 reminding us of? The 2 in 24. Well, 2 is in the tens place. And if you remember, we associated red pairs with the tens place and black pairs with the ones place, single digit place, right? So 24 says 2 of these pairs are red within the each pair, and then we have we have 4. We have 4 black pairs. I'm not sure exactly where they are, but anyway, that's what I'm getting as some feedback here. I'm getting, well, that's interesting too. That means only one of these pairs is of opposite color. What are the chances of that? Only one of these pairs is a red and a black. Otherwise, 2 of them are red and 4 pairs are black. Let's check. Do we have 2 red pairs and 4 black pairs? Well, there's a black pair. Oh, that's good. Oh, here's a red pair. Okay. Oh, another black pair. Okay. Let's see. What about these? Oh, another black pair. We're up to 3. Now, we said we'd have a total of 4 black pairs. We don't want too many black pairs. Oh, wow. We did say that one of the pairs would not match in color. And it was the only pair that would not match in color. Well, we have 1 red and 3 black. So one of these better be a red pair and the other one a black pair. Otherwise, we're dead. Oh, there's a red pair. Okay, we're almost home. We need this to be a black pair. And then my intuition for the matching of these cards within each pair will prove to be 100% accurate. Okay, so what did we get here? Is this a pair of black cards? Oh, it is indeed. Check that out. We nailed it. All of the choices that you freely made led us to an outcome that I was able to sense and state exactly what we would find as we turned over these mystery pairs. Isn't that amazing? 2 red pairs, 4 black pairs, and 1 non-matching color pair. Wow. I wish we could do that every time. Wouldn't that be amazing? Well, you can do it every single time. Why is that? because of mathematics. You can do it every single time. As long as you don't make a mistake, or as long as I don't make a mistake, it will work for you every time. Okay, the last one that we associated with a 2-cycle structure was something brand new. We did some card flipping. Do you remember that? We had cards face up, face down. Now, I don't know if you remember the special number that we just need to remember for this particular routine, okay? So I believe the number that we needed to remember, if I recall, was 40. Oh, yeah, that's what it was. It was 42. Well, how do you think I remembered the number 42? Can you think of 42 being kind of significant in the larger culture? Well, supposedly, in the Hitchhiker's Guide to the Galaxy, the number 42 is the answer to life, the universe, and everything. The problem is no one knows what the question is. We have the answer, but we have no question. Okay, so anyway, let me check. I think that's, yep, 42. So that's how I personally remembered the 42. I just thought, okay, that's silly. It's the answer to life, the universe, and everything. Okay. Now, of course, recall, our association here, right? So the 4, the tens place, was associated with a pair of face-up cards. The ones place was associated with a pair of face-down cards. And then any other pairings left over would be a pair in which there's a face-up card and a face-down card. Okay, so facing the opposite direction. Which is pretty amazing because once again, that means 6 of the 7 pairs will either be facing up or facing down. And then there's only 1 pair at the very end that will be facing opposite ways. That's pretty darn surprising, actually. Now, that will be the case as long as we remember to treat this as a 2-cycle structure and respect that structure as we convert it to other structures and preserve those as well, and perhaps and eventually get down to some kind of a fun reveal. Okay, so since this is a 2-cycle structure, we can convert it to a mirrored structure by performing a supercoat. Okay, so let's bring that up again. Let me bring up my table. Okay, so supercoat is on line 6. Okay, so supercoat, if you remember, this is where you deal out half the cards and then you randomly stack those 2 halves. So it's like 1, 2, 3, 4, 5, 6, 7. And then you ask the spectator, how would you like these stacked? You want left on right? Okay, that's very good. So this kind of coding of the cards is guaranteed to convert a 2-cycle to a mirrored structure. Now, once it's mirrored, we can actually perform an LR shuffle or deal into 7 piles as well as a number of other shuffles that will preserve mirrored structures. So let's go ahead and just do the LR. And then as you're doing this, you can ask the spectator, would you like me to stack the left pile on top of the right or the right on top of the left? It's your choice. That's great. Okay, to convert it to an AMP, on the chart there, if you look at line number 15, it's a B11, so a Bessie 11. That will always convert a mirrored structure to an AMP. So recall how this works. This is where you take 1 from the top, 1 from the bottom, top, bottom, top, bottom, top, bottom, top, bottom, top, bottom, top. Last one goes on top. So this is now an AMP. And so what we're going to do is we're going to do this first shall be last, last shall be first shuffle. So it's FL squared F. It's at the very bottom. It's line 25. And this particular shuffle is actually equivalent to a packet reversal. And that preserves all 3 of these structure types, which is really nice. So if you remember how that works, what you do is you begin dealing out the cards until the spectator says stop. And then you start dealing out into another pile. Maybe they say stop there. And then you deal into another pile. Maybe they say stop there. And then you just keep dealing in this way until all of the cards have been dealt out. And then the key is to be true to the name, first shall be last, the last shall be first, you stack in the opposite order to which they were actually dealt. That's the only thing to remember for that shuffle. And all of that movement of the cards is equivalent to just reversing the order of the cards. Well, if you think about the structures of all three of these, reversing the order won't change the fact that an AMP is an AMP, or that a mirrored is a mirrored packet, or a two-cycle is a two-cycle. Okay, so this kind of mixing of the cards will preserve all three of those. Okay, now what we can do is one, I'm not sure if we've actually used it yet. It's called POE, so its abbreviation is POE, push off even numbers of cards. It's line 19. Okay, so since this is an AMP, as long as we respect the pairings, we can randomly stack all of this together. So for example, push off even, you can ask the spectator for any even number between 2 and 14. And maybe they just say 2, so you push off 2 into that pile. Maybe they'll say 4 this time. Maybe they'll say 4 again, which is fine. Maybe they'll say 2 and then 2 over here. Okay. Now the spectator this time is actually free to stack these in any order that they would like. So you can pick up this one, and then this one can go here, this one can go on top, maybe this one next, and then this one right here. Now this is going to still be an AMP, amazingly. Okay. Now a nice way to go from an AMP to a two-cycle, if you recall, it's the RLR. Now that's line 9 on our chart to the left, RLR. Well, the first R represents random. So it's random up to a point. So if you remember how this works, it's a left-right shuffle. So you go left, right, and then the spectator's free to put the card on either pile. But you don't have to keep going left, right, left, right. Okay, so maybe they want it there. But you do have to build up one level at a time before you go to the next level. So this one, where do you want it? You want it there this time. How about here? There this time. What about there? Okay. This one over there. Okay, and this one here. Okay. Okay, so that's an RLR. And then with random stacking, this will now be a two-cycle structure. Now, once it's a two-cycle structure, you could do Chardelier shuffles or random cuts. There's a whole bunch of things you can do with a two-cycle. But what I'm recommending here is a little different. It's kind of like the previous one here. So what we're going to do is we're going to Chardelier shuffle 50% of the cards, which is 7. And then that will give us 2 halves. And then the spectator is free to have us flip either half. Either half can be flipped. Okay, now for this kind of penultimate step here, I've just realized that the particular finishing for this routine, it works perfectly fine as long as card flipping is not essential to the whole routine. Okay, so I actually wrote this with just kind of a regular routine in mind. I wasn't planning on this. You remember how we randomly flip the cards face up, face down? Okay, so I'm just noticing now that if we do what's here, we're going to destroy information that's important to us from the very start, given how we started this particular routine. Okay, so we're going to have to kind of modify this. This is a two-cycle. Now what I'm wanting is I'm wanting mirrored piles. That's what I'm wanting. Okay, so one way to get that, actually, so in fact, let me just set this down and then I'll write it on the sheet so you can see. So what we're going to do differently than this, okay, that would have worked if all of the cards were face down and we went from there, okay? It's not going to work if the characteristic we have in mind involves whether cards are face up or face down. Okay, so that's the important thing. So what we're going to do to get to mirrored piles is you can just do a deal, I'll write it here, 50%, and then just set down the remaining cards as a second pile. Okay, so why is that guaranteed to give us mirrored piles? Well, dealing 50% and then dropping the rest of the cards on top is a 50% coating. So if you look at our chart, line 5, a 50% coating converts 2 cycles to mirrored structures. Okay, but instead of stacking them to get a mirrored packet, we're going to just leave them separate for the final stage of this routine. Okay, hopefully that makes sense. So if you just deal in half of them into one pile and then leave the other half as is and set it down, those technically, when stacked together, would give you a mirrored packet, or before they're stacked together, they're actually mirrored piles. Okay, and that is something that we've talked about earlier. In fact, let me just bring that up since we kind of had to change things a little bit because I decided to do card flipping for this final routine. Okay, so you remember mirrored piles right here? Okay, so what I was talking about is once you have a mirrored packet, the P down here is push off 50%. So if you have a mirrored packet, which we would here, and you push off half of them and set them down as a separate pile and the remaining cards as another pile, those will be mirrored piles, which is what we need for this swapping procedure. And this is a procedure we have actually used before, so you may recognize that element. Okay, so here we are where, if I haven't forgotten where we are, this is still a 2-cycle. Okay, this is a 2-cycle, and we're just doing something a little differently here, only because the 2-cycle structure from the start was in relation to the orientation of the cards being face up and face down. And if we had gone with this original thing here, it would have destroyed that kind of relationship. If we had just gone with like color matching pairs, things like that, we would have been just fine. Okay, so what we're going to do is we're going to deal out half of them. So 1, 2, 3, 4, 5, 6, 7. So instead of dropping these on top, which would now give us a mirrored packet, we're going to leave it as a separate pile. Well, these piles now are mirrored piles, okay? So every mirrored packet, if split in half, gives rise to, quote, mirrored piles. Well, maybe just to remind you, what are mirrored piles? This is where the top card here is related to the bottom card here, okay? And the same thing, the top card here is related to the bottom there. So there's kind of this mirrored relationship between these two halves of packet. Okay, and so now, because these are, quote, mirrored, we can actually do this really fun swapping procedure. Do you remember that? So since we have 7 cards all together, we have 6 free swaps. The spectator can allocate however they would like. So maybe they'll say, okay, perform 2 swaps on this half. So 1, 2. We have 6 total, so we have 4 more that we can do. So 1, 2, 3, 4. Okay, you just kind of set those aside like that. Okay, and now we have 5 swaps left. Okay, so maybe they'll do 3 here. 1, 2, 3. Very good. And then 2 here. 1, 2. Okay, and then set these down like this. Now, it is true, I just realized, it's not a big deal, but I just realized that we're going to see the end result doing it this way. It would probably be best, right before we do this, to go ahead and either like write out a prediction or have the prediction this time, maybe have this prediction written out, that there will be 4 face-up pairs and 2 face-down pairs. Okay, so have that written on a piece of paper and set aside or something, or state it before we begin the swapping procedure. Because if we actually go through all of this, we'll see what the outcome is, and then if you say, oh, well, in my mind's eye, I was seeing the number 42, and it means 4 of the pairs are face up, two are face down, and you've already seen that that's the case, right? Does that make sense? Okay, so some of this little tweaking at the end is because I decided to throw in this randomly mix the cards face up and face down and have that as characteristic of interest, okay? So before you actually do this, you'll need to let the spectator know that you can see the future, that you can see what's going to come from all of this, okay? So it's now, so just assume now the spectator has been told by you that after we're done, somehow we're going to end up with 4 up-facing pairs of cards, 2 down-facing pairs of cards, and there'll just be 1 pair that has an up-facing and a down-facing card. Okay? So anyway, that's kind of important here because we're actually seeing it being confirmed in real time here. So to make it a surprising prediction, you need to let them know that you know what's going to now happen. Okay, what are we're down to 4 swaps, right? Total. So maybe the spectator says, okay, perform 2 here, and then 2 over here. 1, 2, very good. And then set aside this pair, okay? And what's nice is if you've already stated there's going to be 4 up-facing pairs, 2 down-facing pairs, and 1 pair with opposite orientation, the spectator can kind of see how is he doing so far. He said we'd have 4 of like this face up. We have 2 so far, and then he said there'd be 2 face down pairs. Well, we have 1. Let's just see how this works out. Okay. Okay. So we're down to 3 swaps, I believe. So how would you like these allocated? Okay, and what's really cool, I guess, in some ways about this, what makes it really powerful is if the spectator now knows what your prediction is for the outcome of this, they're going to think long and hard about how to allocate these swaps. They might even try to kind of look ahead and go, let's see, I'm going to allocate those numbers in such a way that it destroys his prediction. I'll show him, Okay, so it's 3 swaps, right? So 1, 2 may be allocated there. It's a free choice by the spectator. And then 1 here. Set aside that pair. Oh, wow, look at this. Okay. So we've already predicted that there would only be 1 pair that's facing the opposite way, right? Different orientation. Oh boy, we cannot see any more of these. Otherwise, our prediction is dead, right? Okay, so what are we down to? We're down to 2 swaps. How do you want them allocated? Do you want both of them over here? Okay, 1, 2. Oh, good, look. Yeah, we got a down facing. We said we've seen in 2 up facing. We have 2 now, right? How would you like to allocate the remaining one? Over here. So we have 1 swap remaining, and you can allocate it on, so this one, okay? So set aside that pair, and then these are a pair. So how did we do? Our 4 pairs facing upward, 1, 2, 3, 4, and our 2 pairs facing downward, 1, 2, and is there 1 pair that's facing the opposite way? There is indeed. How in heaven's name were you able to do that? Okay. Okay, so I apologize for having to make that adjustment at the end. A lot of these performances, I make up the narrative on the spot in real time. And so the fact that I decided to kind of go with card flipping here, it would be affected by what I had done here. But if we had not done that, we could have gone through with exactly... Oh, in fact, let me just explain what this means. Charlier 50%. Let me just explain what we would have done if the cards were all face down and we were just counting like the number of red pairs or black pairs. Let me just explain that. So what is this? Okay, so assume this is a 2 cycle. That's kind of where we were relative to color or something, right? So what's the Charlier 50%? Well, what you do is it's a Charlier shuffle in which you move half the cards into your other hand. So maybe I move 2 here from the top, and maybe 1 from the bottom, and then maybe 1 from the top, and then 2 from the bottom. You just have to keep track of, like, you know, how many we have. We have 6. And then I would just need 1 more on the bottom, okay? So that gives us 7, okay? So we'd have 2 piles of 7. Well, it ends up that because it was a 2 cycle before doing this, if we now randomly flip either half, relative to the colors of the cards, if that was the characteristic we went with originally instead of the orientation of the cards, this would now be set up. These would now be mirrored piles for which the swapping procedure would work perfectly. Okay, so I just wanted to explain that it would have worked just fine if I hadn't kind of changed how to present this last routine today here for 2 cycles. Okay, wow. Well, thank you for watching and for sticking to the end. We'll be putting out another video. It'll be a 16 card packet video next. And as you might guess, the packets are getting kind of big, so we have to get creative as to what we do with them. But I do want to remind you of something I said earlier in one of our videos in this series. Like with 16 cards, if you see something interesting with like the top 8 cards and the bottom 8 cards separately, there's nothing wrong with just breaking up that packet of 16 into 8 and 8 and then perform the kind of routine that we did with a packet of 8 cards, okay? Or you could break it up into 10 and 6. Those are packet sizes that we've used, right? So anyway, that's kind of where we're headed. I don't know if I'll use that particular principle or not, but we may. So thank you again for watching, and take a look at other videos on the Hidden Structures channel.